Hey everyone, welcome back to AI Chronicles. My guest today is Danielle Marques from Google DeepMind, and we are going to talk about research, real world AI systems, and some of the trickier questions around how LLMs reason, remember, and even evaluate each other. But before we get into the technical side, Daniel, hi, how are you doing?
Hi. Good. How are you?
So far, so good.
Thanks for
How's
having me.
life at Google DeepMind?
It's good. It's good. It's been for me. It's been almost 2 years now since I've joined. So I've already joined at the height of the LLM
I bet,
world,
yeah.
and yeah, it's it's quite fast paced. As I think
Hmm.
the industry is. I feel like every week there's something that happens. So there's no boring week
Oh,
during
yeah.
those times. But it's really fun. It's really fun, especially to be sort of like at the frontier of this thing and getting to see the models as they're being built. So like how the sausage is made, it's quite interesting.
Nice.
Yeah.
Why don't you tell us a little bit more about your role or any interesting projects or research that you're working on that you can share briefly?
Mhm. Yeah. So I'm a software engineer on the Gemini app side. So my team was the one that shipped Gemini Canvas
Mm,
earlier this year. So depending on the types of queries you have, we can open it on the right side, and you have so like this split screen mode where you can either edit a document if you're writing an essay and talk to Gemini about it at the same time. You can also do this for code. So for some languages like React, we can even do the preview. So you could ask for like a web app, and it does a preview there. You can build games out of it. I've seen people building multiple things. You can build. One friend built a mix of Tetris and Brick Breaker, so it was
Oh,
it was
wow.
really cool. Yeah, it would change it at midway thing, basically by prompting the model to get it to work, and you can see it play. So yeah, so I've been in this team ever since we started with this project. I do basically technically the evaluations part of it. So a lot of
Mm,
the every change that we make, we have to run a bunch of evals on these things and to make sure that the quality is
yeah.
at a good level. Yeah.
Nice. So the canvas, that's completely multimodal, or is it only for images or text or something?
It's images, text. Well, I mean, we generate code, we generate
Hmm.
text, right? We do have images that we can put it there, so you can build apps that use Nano Banana. This was
Hmm.
big hit a couple months ago when Nano
Hmm.
Banana launched. We had all sorts of apps that would,
Nice.
take your image, make it look into an 80s band or something. There's all sorts of things there.
I'll confess something. I have not tried the nano banana as
Oh,
much
really?
as the name sounds so intriguing and
Yeah.
funny. Tell me what it does. Like, is it something that somebody built, or is it what is it
Yeah.
exactly?
It's an image generation model, so
Okay.
text to image.
Hmm.
It also takes images input, so you can send
Okay.
uh, two images. And for example, people have done a lot. They would send two images of themselves now
Hmm.
and themselves when they were 3 years old. And the Nano Banana basically creates an image of the two of them together. So it looks pretty cool. There's so many things that you can build, and the model is just really good. That's the
Nice.
thing that really it changed things.
That's pretty cool.
Yeah.
Nano banana. I wonder who came up with that name.
It's a funny story. People have talked about it. It was just chance. Like I think they were doing this at some point in midnight, and they had to come up with a name. And I think that the woman who said it, her name is Nana, and then Nano because the model is small, so Nano
Uh-huh.
Banana, and it wasn't supposed to be an external name, but it turned out that it ended up being an external name. And to me, I think it's the most. When you join Google, they talk a lot about what the Google culture and being googly actually means, and I feel
Mm-hmm.
this name represents it perfectly. Like I think it's just a perfect name.
Nice. I really
Yeah.
love the name Nano Banana.
Yeah.
It went viral, I must say that.
It
I
did. It
kept
did. Oh,
seeing on Twitter
yeah.
like so much. But yeah, thanks for sharing what it is. I'll definitely give it a shot.
Hmm.
Okay, so let's get some bit technical.
Yeah.
DeepMind's research often pushes the boundary between pure science and practical AI, and I feel like the entire world is a witness to that. From your perspective, what's the most exciting research direction right now when it comes to large language models, and especially in how they're being applied beyond just text generation? Like we were just
Mhm.
talking about
Mhm.
text to image and such.
Yeah, I think DeepMind has this. Last year we got the Nobel Prize for the AlphaFold, right?
Mm-hmm.
And I see this. I don't work in these applications for these medical domains or research biology or chemistry, but I feel like this is something that you know yeah, everybody sees the Nano Banana, the new images because they're cool, they go viral. But there's a whole thing happening, at all the PhDs in
Mm-hmm.
biology and in medical research. Their world has also changed quite a bit,
Yeah.
like in the sense that now they have access to this model that can, AlphaFold predicts a protein.
Mm-hmm.
Structure. And last week we also released, I think it was Cell to Sentence, if it was over the news, which is still text generation, but it's basically a model that was able to come up with hypothesis to be tested on the lab for
Mm-hmm.
cancer research. And it turned out that the hypothesis was true. So
Mm-hmm.
the model did help the scientists make this sorts of advances. So and it's all transformers based. It's also when you use these generative models, it started almost like, oh, you can chat with it, you can do all of this, sort of like you're playing with it, right? But
Right.
then there's all this whole world that opens up. I think it's something that's really cool to see this technology being applied there.
Yeah, I
Yeah,
bet, I bet. And like, yeah, this technology being applied in so many different aspects of just technology. It's very, very
yeah,
interesting. And
yeah.
we have seen like large language models starting like they started powering everything from coding assistants to reasoning engines. Now, how do you think that we should be thinking about their application? Like, are we at the stage of refinement or are we still fundamentally experimenting with this behavior? Or with their behavior.
I think I think both.
Mm.
I feel like if we stop any research right now, we
Mm.
still have like a decade of work to do to get these things into people's applications. Like the number of places that you can build new things with these models as they are today is
Mm-hmm.
already insane. And it's something that we don't know. Like I talk to
Right.
friends who are in different industries
Mm-hmm.
and they say how easy it is to apply these models into things that I had no idea, right? And I think that's why you see so many startups coming up.
Yeah.
You can apply this to the legal domain. You can apply this to an accountant. I mean, I don't know how an accountant works, but it turns out that something might work really well for them. And there's no way that somebody at DeepMind will think about it when they're building the model. So,
Right.
like even if we just take the model right now, there's so much that can be applied in different domains that we had no idea.
Mm-hmm.
And the models are still evolving, right? So
Yeah.
there's still, step changes that can happen. I remember earlier this year, when we launched Gemini 2.5 in March, the difference from 2.5 to 2.0 is insane, right? I mean, a lot of things that you couldn't do at 2.0 out of nowhere, 2.5 is able to do it with a simple prompt. So, you know, I, I I think there's a lot that can be unblocked by just some changes that these models do,
Mm-hmm.
and it's just even hard to know what that will be, right?
You were talking about like how the models are evolving, and you're right. Like there is always, Gemini 2.5 or some other model. They come up with their next version. So like
Yeah.
when you mentioned going from 2.0 to 2.5, what are like those changes that you think happened, and why is the 2.5 much faster? Or is it more like suitable for specific tasks, or it just like performance wise it became better?
I think you knock it out of the park everywhere. It's I think you shine even more for more complicated tasks, and I think maybe that's where
Mm-hmm.
the next things will come because if you're asking simpler questions, I think every even the when I use Gemini, I don't. If I'm asking a simple question, I'm not going to use the pro model because it's just going to take longer and it's just going to give me a
Right.
response. It's just as good as a smaller model. So when I say it unblocks new things, because sometimes with harder tasks that the 2.0 model had a problem with, then
Mm-hmm.
2.5 just does it and replies super fast. I think that's where it shines the most. There are some questions that the smaller model works, and you don't really need any new that many new advances there. So
Makes sense. And do you think like the smaller models are really what they call small language models? Or it's just like,
I think the definition of small changes a lot. I
It's
remember when
yeah.
I used to work with my previous job, I worked with, Bert, Roberta, and what we had at the time,
Mhm.
like pre
Oh
2022.
yeah. Wow. Yeah,
Uh,
Roberta's.
I mean, those were exactly, those feels like 20
Yeah,
years
those
ago.
feel like small language models to me
This
now.
feels like very small language models, right? And
Yes.
they're already 300 something million parameters, right? They were not, at
Yeah.
that time, we didn't think they were small at all. We
No.
actually couldn't use sometimes the BERT large because it was
Mm-hmm.
too large.
Too resource
Uh,
intensive too on the
yeah,
machine.
exactly.
Yeah.
They've always
Mm-hmm.
been, right? I think there has been a lot of work that, if you look at the models right now, with not only they've always been getting bigger, and I think that has worked for the industry ever since, forever.
Mm-hmm.
I mean, at some point this has to stop, but they are more efficient. I think 1 billion parameters today gets you farther than 1 billion parameters a year ago. 3 years ago, you wouldn't even think to have 1 billion parameters in the
Yeah.
model.
No.
It was out of option. So
Yeah.
yeah,
Yeah. 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 Okay. And also, like, since we're talking about LLMs so much, and you mentioned that you have experience in evals,
hmm
and I feel like LLM evaluation or agent evaluation, that's like an ongoing debate
yeah,
online. That's what I keep hearing and
hmm
reading about. So there is this growing trend of using LLMs as judges, which, by the way, whenever that idea came out first, I'm like, what?
hmm
Um, uh, to evaluate other models outputs or even guide reasoning. Do you think that's a reliable approach, or are we introducing new layers of bias and uncertainty?
We are introducing new layers of bias and uncertainty, yes. With anything, I mean, with humans and with
Yeah.
new guidelines, every time you write, you always have that.
Mm,
But I'm a big proponent of that. I think LLM as a judge, and this is a lot of my, my bread and butter here, is that it really helps the development of things in terms of speed. Uh, yes, they're not gonna have the same quality as you send these things to a human and everything. But the thing is, if you want to send this to a human, you create a model and you're gonna have to wait days for the thing to come, and it's gonna be very very expensive, right?
correct.
Uh, if you are able to have an LLM to give you a judgment, and yes, it's not perfect, but the thing is, when you send this to a judge for even for a rater, you not you don't necessarily need it to be perfectly correct. You just need that given two model A and B, which one is better, right? And that
Mm,
already gives you the direction that you're going. So if you have two ideas that you're testing it out, you just want to know which one is better because then you go and follow towards that direction, right?
mm,
And
mm,
of course, if you send this to human raters, you wait a week to get the results, or however many days, you get like a perfect number. Model A is exactly 17.5% better than Model B,
mm,
right? But sometimes you just need to know that Model A is better. So
mhm,
if you can get this with LLM as a judge, and it takes like 2 hours to get the number, versus sending to a human that will take 100 times, it's 100 times more expensive, and it will take whatever, five
mhm,
days and 3 days, like if you can push. So I think if you're building products with LLMs, LLM as a judge is a really, really good idea to get the team to move fast. Like you can have multiple engineers working with it
mm.
and you just get the results faster.
Okay, I think I understand what the advantages are to this idea. Now, I'm curious. So, when you have an application that uses LLMs and or two different models, how do you pick which LLM could be the judge?
Yeah. Uh, Bigger the better, right? And in this case, you
Really?
can wait a little longer. When you're using an LLM, you want to get the response in right away. If you're doing this judgment, if the LLM, if you want to use a very big one that has thinking, etc., and it takes a few seconds to generate, it's fine, right?
Mhm,
You're running this using parallel, it doesn't matter that much. So yes, the bigger the better, but of course, when you have this, you have to have a human baseline or some sort of baseline to compare. Uh, I think it's hard for you to, I'm just going to prompt it and I'm going to trust that it's going to work. I
mhm,
think that you can get into, I think the cost of that when it doesn't work, it's too expensive because it sends the team to the wrong direction. And then you're just going to waste all of the engineer's time pursuing something that exactly, it's actually not good. So So yeah, it's something to take into account, the size of the model and which model to use.
Honestly, when you mentioned like the bigger the better for the judge model, I
Mm.
thought that it would be opposite. Like we would want the judge model to be smaller because its only task is to judge the quality of one versus the other. That's what how I
Uh,
was thinking.
right. But the thing is, a lot of the times, the things that you're judging, they they could be these more not super
Uh,
objective things. So you do want to have a model that can think through. Otherwise, it's very easy. For example, one big problem with LLM as a judge, they love long responses, right?
oh
So they are
yeah.
very biased towards that. They're often, if you're doing sides by sides, they're often biased to one side, just whoever comes first, or whoever, like there's a lot of these things that come. Smaller models, I think, have even more of that.
Mm,
Uh, but if you have a model that, that's longer or that can explain its thinking better, like, look, I am giving this rating because da 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 da, da, I think that helps. Uh, if you're measuring something that's very specific, sometimes you don't even need a model, right? If you just want to check if you know the LLM you're testing outputted some token,
mhm.
then you just go and
Yeah.
check it. Maybe something more specific, and I think that's even better, right? I mean,
Yeah.
ideally, you don't have to send this to a complicated model at
Hmm.
all, right?
Makes sense. And do you think the LLM as a judge are used for not only the text-based applications but also for different modal modalities?
Yeah, I mean,
Okay.
then it's a bigger model. If you want to send
Yeah. Then
images to
yeah, I
it
bet.
and
Yeah.
all
Yeah.
this stuff, it gets more complicated. But uh, you know, this multimodal models, they also do decent, image analysis. Like if you send Nano Banana and you can ask it not just to generate a new image for you, but it also understands an image. Like if you ask for a description of the image, it'll do a good job at it, right?
Mm. Okay.
Uh, yeah, another dimension, it's more complicated, but still works.
Makes sense. Got it. This is a fascinating topic. I could keep
It
asking
is.
more questions to you. If you had to imagine the next leap in LLM research, something that could redefine how we use or trust these systems, what would that be?
Yeah. So a lot of times what we say here is, speed is a feature, right?
Hmm.
Speed is a feature of your model. So having the response faster sometimes beats having the response who's a tiny, tiny percent better that really, really nobody's gonna notice, right? So uh, I think there's a lot of these more complex models, and even if you're doing coding, for example, that you kind of have to wait a little bit. I mean, if you go in Gemini Canvas, right, and you ask for something more complicated, like a web app that's this and it has that and that, it takes time, right? Or you want to make a change, or you have to wait sometimes, a couple minutes for it to get it. Or so I think, we've done a lot of work of scaling this up, and we haven't stopped. We're still scaling
Yeah.
the model up ever since GPT. I know GPT-1 was good, and then GPT-2 was basically, hey, scaling is better. And then,
Yeah.
they
And
kept
then
doing it
it
until
just like,
GPT-3 was like, oh, wow, scaling up is really,
yeah,
really better. And that's when everybody,
yeah,
so we've been scaling up since BERT came along, right?
yeah, yeah.
Uh, but I think speed is also something that will change, especially for more complicated tasks.
Hmm.
And also the context, right? I think was it this year or last year that Google launched 1 million contacts? I think it was last year.
Probably.
So when we launched 1 million contacts, it felt like it was okay. Nobody's ever going to need that. And I was talking to a colleague the other day, and it felt like the Bill Gates quote that well, I think 600 kilobytes. Like nobody's ever going to need more than 600
Oh my
kilobytes of
God.
memory. This was like back in the 80s or 90s.
Yeah, gone
And
were
I
those
felt like
days.
yeah, exactly. I felt like the 1 million context will become one of those. Like, oh,
Yeah.
nobody's ever going to need more than 1 million. And now we'll be like, oh, yeah, actually, if you're working on a large code base, you kind of need more than 1 million tokens, right?
Mm-hmm.
In the
Mm-hmm.
context window. So, and who knows, maybe if you go to 1 million to 1.5, you start unblocking a million different things that can't be done very well today. So I think these two things, if you have something fast and that can just look at more and more data and do the attention right at
Mm-hmm.
this type of data, which that's a real challenge.
Mm-hmm.
I think that unblocks a bunch of things.
Very cool. I remember what question I had
Okay.
earlier when we were talking about
Yeah, yeah.
evaluations. Do you have you worked with any agentic application when it comes to evaluations at all, or like have you seen people use LLM as a judge to evaluate the agent's performance? Just curious. If not, that's
I think maybe I think it depends on how you define the agent, but I see no reason why you wouldn't. But
fine.
you should not, and I think this goes for human raters as well. I mean, you shouldn't be asking too broad of a question when you're doing
Mm-hmm.
these evaluations. I understand that you want to do an evaluation end to end,
Mm-hmm.
but just asking like which is better with that's something that's too complicated, you often get a lot of the you get some responses that might be focused on one thing. LLMs
Mm,
tend to do this a lot. If you ask a question about that's something that's too complicated, it'll
right.
pick one aspect and then say, "Oh, it's so good because this aspect worked really well," and it just ignore everything else. So
Okay.
I wouldn't use it for such a long thing, but you're
Mhm.
using it multiple steps along the way.
Got it. So what I'm understanding is that being specific really helps when you're
Oh
using
yeah,
LLMs as a judge instead of too
that
broad of a thing. I mean,
that already helps. Yeah, that
yeah,
already helps with humans. People are
yeah.
a
I
lot
was
more
gonna say that.
objective if you ask these questions, and with
Yeah,
LLMs, you have to be extra more than
extra
that.
specific. Got
Yeah.
it. Got it. Wow. Okay. I could keep going with the questions, but
Yeah.
with respect to time and attention,
Yeah.
this was really an insightful conversation, Daniel. And I loved your take on how research translates into real world AI systems and lots about the evaluations.
Mhm.
Thanks again for tuning in. And everybody listening, as always, stay curious and keep exploring where AI is headed. Thanks again, Daniel.
Yeah. Thanks a lot. Thanks for the invite.